Hey everyone, and welcome to another deep dive. So, get this. Scientists have figured out how to control atoms using light.
Hmm. Impressive.
I know, right? It sounds like something straight out of science fiction, like we're talking about manipulating the very building blocks of, well, everything.
It's certainly a remarkable achievement, and it's not science fiction anymore. This is real-deal research, published in Nature, no less.
Exactly. And that's what we're going to unpack today, just what this breakthrough means, why it's such a big deal, and what it could mean, for the future.
What's really groundbreaking here is that we're moving beyond just observing the quantum world. We're actually starting to manipulate it.
That's a good point. It's like we've gone from just watching to actually getting our hands dirty, so to speak.
Precisely, and with incredible precision. Imagine using light as a tool to, well, tweak and control individual atoms.
It's like having tiny little tweezers for the universe, but how does it even work? What did these scientists actually do to, pull this off?
Well, they use something called extreme ultraviolet light, or XUV for short. XUV.
And they used it in these super fast pulses, to directly influence the energy levels of helium atoms.
Okay, so we're talking about lasers here, right?
Right.
But XUV light, is that like some kind of superpowered laser beam?
You could think of it that way, yeah. XUV light has a much shorter wavelength than visible light, and that allows it to, well, interact with matter on a much, much finer scale.
So it's like having like a scalpel instead of a butter knife when you're trying to do delicate surgery, but on an atomic level?
That's a great analogy.
So they're basically using these super precise XUV lasers to nudge atoms around, kind of like tiny billiard balls.
It's a bit more nuanced than that. They're not physically moving the atoms around, but rather changing their energy states. Think of it like tuning a musical instrument.
Okay, I see. So by using these pulses of light, they can make the atom, vibrate at a different frequency, and that changes its properties?
If they can change the way atoms behave, does that mean they can potentially change how those atoms interact with each other? Could they actually create new molecules or materials?
Now, that's the exciting part, you see. Being able to control atoms at this level opens up a whole new world of possibilities in, well, countless fields.
It's pretty mind-blowing, but creating new drugs and materials, even if you can control atoms with light, that's still not exactly simple, right?
Of course, there's still significant challenges to overcome. One of the biggest is, well, scaling this technology up. Right now, they've demonstrated this control with helium atoms, which are relatively simple.
Right.
Applying this to more complex atoms and molecules will require, well, significant advancements in both the technology and our understanding of, these interactions.
So while it's a huge breakthrough, it's still early days.
Absolutely, but the potential impact is immense. Imagine a future where we can manufacture highly specific drugs with far fewer side effects or design materials with properties we can only dream of today.
Yeah, it's almost hard to wrap your head around all the possibilities.
It really is.
But if we're talking about revolutionizing entire industries, like you said, there must have been a massive team behind this research, right?
You're absolutely right. This was a global effort. The research was conducted at the Elettrosynchrotron in Trieste, Italy.
Yeah.
One of the leading research centers in the world.
Wow.
And get this, it involved the collaboration of 14 different international research institutions.
14? That's incredible. It really shows how much, teamwork and collaboration is needed to push the boundaries of science like this.
Definitely.
So with all these brilliant minds working together, what kind of future do they see for this technology? Where do they think this is all headed?
Well, this discovery could have far-reaching implications, not just for medicine and material science, but potentially for fields like quantum computing and communications as well.
Okay, now you've really got me hooked. Quantum computers, faster communication. This is getting really interesting.
It is, isn't it?
But before we get too far ahead of ourselves, let's maybe dig a little deeper into those specific applications you mentioned.
Sounds good to me. So let's start with chemistry. Imagine being able to orchestrate chemical reactions with, well, atomic precision. It'd be like a conductor leading an orchestra.
So we could potentially unlock a whole library of new materials with properties we haven't even, begun to imagine.
Exactly. Think about materials that are, say, lighter yet stronger, or materials that conduct electricity with virtually no resistance.
So I'm picturing a world with self-healing materials or clothing that adjusts to the temperature, maybe even buildings that can generate their own energy. It's just like something out of a science fiction novel.
It certainly is exciting to think about all the possibilities, and let's not forget about the potential impact on medicine. This technology could usher in an era of, well, personalized medicine tailored to your specific genetic makeup.
Oh, wow. That's incredible. So, like, drugs that target only disease cells, leaving healthy ones untouched.
Precisely, fewer side effects, more targeted treatments, and potentially even cures for diseases that are currently considered, well, incurable.
It's a total game changer, but I'm curious, how far away are we from actually seeing these applications become a reality?
Well, it's important to remember that this research is still in its early stages. There are still, significant challenges ahead, but the progress being made is really quite incredible.
So while we might not have flying cars or teleportation just yet, this discovery is definitely a big step towards a future where we can like manipulate the building blocks of the universe with, well, incredible precision.
That's a great way to put it, and it really highlights the power of human ingenuity, and the importance of international collaboration.
Well said. Speaking of which, does this technology raise any like ethical concerns? I mean, if we can manipulate matter at such a fundamental level, are there potential risks we need to, be aware of?
That's a crucial question, and one that scientists and society as a whole, well, need to grapple with. As with any powerful technology, there's always the potential for misuse.
Right, right.
We need to ensure that this technology is developed and used responsibly with, well, careful consideration for its potential impact on humanity and the environment.
Yeah, it's a reminder that with great power comes great responsibility, but I think it's also important to remember the incredible potential for good that this discovery holds. I'm really eager to see how this field evolves in the coming years.
Me too. It's a truly exciting time to be alive, and I think we're just at the beginning of, well, a new era of scientific discovery.
It really does feel like, we're on the verge of something truly groundbreaking, a whole new era of, well, technological advancement, all driven by our understanding of the quantum world.
I agree. It's an exciting time to be alive, that's for sure. And it's a little bit daunting, too, would you say?
Oh, absolutely. It's a reminder that, the universe operates in ways that we're only just starting to, like, scratch the surface of.
Exactly. And as we unlock these secrets, well, we have a responsibility to use this knowledge wisely.
Well said. Today, we've really gone deep, no pun intended, into this incredible breakthrough, scientists controlling atoms with light. You've explained how it works, using those super fast pulses of extreme ultraviolet light to essentially tune the energy levels of atoms. And we've explored just how groundbreaking that is, from revolutionizing chemistry and medicine to potentially unlocking the power of quantum computers and even, faster than light communication.
And it all stemmed from a single research article in Nature, which I think speaks volumes about the incredible pace of scientific discovery these days. Who knows what other breakthroughs are just around the corner.
All right. That's what makes it so exciting. It feels like we're standing at the edge of this vast, uncharted territory, just full of possibilities. And that brings me to a final thought I want to leave you with. We've talked about the practical applications, the potential benefits, the risks even. But what does this discovery tell us about, like, the nature of reality itself? If we can manipulate the very building blocks of matter, does that change our understanding of what's possible, what the universe is made of, how it all works?
That's a profound question, and one that I suspect philosophers and scientists will be debating for years to come.
It's a big one for sure.
But perhaps that's the most important takeaway from all of this. You see, this discovery isn't just about new technologies or scientific advancements. It's about expanding our understanding of the universe and our place within it.
I think you've hit the nail on the head there. This deep dive has given us a lot to think about, and I hope it's sparked your curiosity as well. Thanks for joining us on this incredible journey of exploration. Until next time, keep asking questions, stay curious, and never stop exploring the wonders of the world around us.